Yes. Here we go. Today we're going to talk about what happens when you apply a multiplier. So suppose we take a multiplier like a and put it on the outside of the function. Will that affect it vertically or horizontally? Vertically. And in fact, what this will do is we'll call vertical stretch. By a factor of a. Now, to show you the difference, if you had, say, y is equal to 3x squared, what do you think the 3 is going to do to that parabola? So I see this. I like what you guys are saying with the motion of your arms. Your idea is it's going to make it bigger, right? Bigger depends on horizontally or vertically. So is the 3 on the outside or inside? Outside, so it's going to impact it vertically. It's going to stretch it. Okay? So this is going to be a stretch. Whereas if I look at a slightly different one, say y is equal to 1/4 x squared, do you think that that will be a stretch or a shrink? It will be a shrink. What's that? You could say compression. Sure. Yeah, we want to stay away from descriptions like skinny or wide, because a lot of it really depends on the direction that we're stretching it. So let's look at this next part. Suppose we have g of x is equal to f of b times x. Is the b on the inside or outside? It's on the inside, so that's going to excuse me, that's going to affect it horizontally. That's going to be a horizontal shrink by factor 1/b. So on the inside, it's opposite of what you think. When you see it on the outside, you could say, oh, it's going to multiply it by whatever number you see. On the inside, it's opposite, so it's your reciprocal value. So we'll show you an example here. Suppose you had y is equal to 3x raised to the 4th power. Okay, suppose you have y is equal to 3x to the 4th power. Is the 3 on the inside or outside? It's on the inside. So is that going to affect it horizontally or vertically? Horizontally. And it's going to do opposite of what you think. It's not going to stretch it by a factor of 3. It's going to shrink. Whoop. Shrink by what? Good. So when it's on the inside, it's opposite of what you think. Suppose we had y is equal to 1/5 x raised to the 4th power. Will that be a shrink or a stretch? Stretch by a factor of 5. Okay. All right, so let's put all the pieces that we've talked about together into one summary. You see this y is equal to a times the function of bx minus c plus d. Let's look at exactly what this what happens here. Let's check out y is equal to, it will say -2 times the absolute value of 4x minus 12 plus 5. Lots going on there, isn't there? I think it's easiest to talk about the function by looking at the outside parts first. I find the inside to be more confusing. Would you agree? So let's start with the easiest. What's this plus 5 going to do? Good. It's going to be a shift up 5 units. What's my other number that's on the outside? So what's the negative going to do? Good. The negative is going to be a vertical reflection. What is the 2 going to do? Stretch vertically or horizontally? Vertically. Vertical stretch by 2. You okay with those two? Okay, let's look at the inside. And what I notice on the inside is I have that 4 times the x, but I like to factor the 4 off. It's going to help me understand better what's going on. Maybe you saw an example like this yesterday. We'll do it 4 times x minus 1. And when we factor the 4 off, it's going to be easy for us to be able to determine what happens there. That is going to happen at x minus 3. Right, 3 units. So you can see that if I factor the 4, people will think that maybe the shift was 12 units, right? When in fact the shift is 3. And then finally, this 4 is not going to create a horizontal line or a horizontal stretch. Good. This would be 1/4 horizontally reduced. This can be a super confusing process. I mean, we could take transformations of these operations. We could put a rate or 2 on it. We don't want to do that. We just want to horizontally reduce. So I've selected a problem or 2 that you would be asked on the ACT. I mean, that's our biggest goal, right? Number 1, you want the ACT to prepare for calculus 1-4. And so this type of problem is going to be what we're going to do, and you're going to do this on your assignment, so important is we're going to draw an example function that these sides, and I'll apply it up here and change that one. But I'm going to apply -2, -2, 0, 2, 2, 2, and then 0, 3, or 3, 0, excuse me. And we're going to make that shape. So go ahead and take a minute and shape, and also write down on the right-hand side. So the other day we looked at parent functions. You know, we looked at those different shapes. Today we're going to look at a shape that's not one of those from our functions. But we're going to predict its shape based off the transformation. We're going to give a new set of coordinates for those 4 points. Okay? So we're going to make it really easy. Are you ready? Look at our first example. This is f of x here. We're going to produce 2 times f of x. Is the 2 on the outside or inside? So is that going to impact it here vertically? So impact it vertically, is that going to change the x values or the y values? The y values. So what we're going to do is we're going to produce a new set of coordinates, that's y, that model 2 times f of x. You told me that the 2 affects it vertically, not horizontally. So therefore, I am not going to change my x They stay the same. Negative 2, 0, 2, and 3. But what do you think happens to my y values? They double. So therefore I have negative 4, positive 4, and 0. And I'm going to sketch that graph right here. It should look the same. It should just be vertically stretched by a factor of 2. Does it look like it's stretched vertically? Can you tell it is not pulled horizontally at all? That's very important. You good with that first one? The next one, what does the 0.5 do? Okay, I hear a lot of good things. Let's first all agree it's on the inside, right? And if it's on the inside, it's horizontal, and it's going to do opposite of what we think. So multiplying by 0.5, that would generally make it smaller. But when it's on the inside, we think about the reciprocal. What's the reciprocal of 1/2? 2. So this is going to be a horizontal stretch by a factor of 2. If it stretches horizontally by a factor of 2, is that going to change the x values or the y values? It's going to change the x values. So what do you think I'm going to do to the x values? Yep, I'm multiplying by 2. Can you see on the test why people would multiply by a half? Yeah, we don't do multiply by a half. We multiply by 2. So we get negative 4. We get 0, 4, and 6. All right. X, horizontal. This was a vertical stretch. All right, now the +1, what does that do to a function? Shifts it up 1 unit. So is that going to affect the x or the y? So what do you think we're going to do to the y values? Add 1. You see, when it's on the outside, you do exactly what you think you're supposed to do. When it's on the inside, you got to think opposite. So we're going to add 1 to those y values, and I get negative 1, 3, 3, and 1. I'm going to sketch that, and my sketch should look like it's stretched horizontally. Again, I'm using this sketch as a visual check. Does it look like I pulled it horizontally? I sure did. And it looks like there is a little bit of a shift up. Uh-oh, we got 3 things going on in this next one. Where do you think we start, with the negative or the -1 or the -3? Yeah, you start in order of operations. And so order of operations would start on the inside and then work your way out, right? So what does the -1 do? Right 1. Thank you for saying it that way. So that's going to change the x values. What do you think we do to the x values? Right 1 would be adding 1, correct? So do you see that it says -1, but right 1 would be adding 1. So we're going to add 1. So again, opposite of what you think. So negative 1, 1, 3, and 4. Okay, what does that negative do? Okay, reflects it vertically or horizontally? Vertically, so that's going to change the y values. So it's going to take all these y values and make them opposite of what they were. Okay? And then, after that, we're going to subtract 3. So let's make this opposite. So we change it from -2 to, and we subtract 3 to get -1. And we change this +2 to -2, subtract 3 to get, we got another -5, we got -5. we have a negative 3. So this one should look like it's flipped upside down, right? I'm going to sketch this, negative 1, negative 1. 1, negative 5. And it looks like I've got the same shape. It looks like it's flipped upside down. It definitely looks like it's shifted down 3 and over 1. I like my work so far. Looks like it's really matching up. I want you to talk for 30 seconds with those around you to try to predict what's going to happen here. Okay, talk about the last one with your peers. What's going to happen for the last one? Go, talk. Okay, what'd you get? Who's going to give us a summary? All right, let's go. Yep, go across the y-axis is a horizontal flip. Okay. Excellent. So this is going to affect the x values. So it's going to be a horizontal reflection. So we take all those x values, we just switch them, right? So let's do that first. So we're going to be positive 2, 0, negative 2, negative 3. Then Marissa said that we're going to stretch it by a factor of 2, and after we stretch it by a factor of 2, then we'll shift it 2. So notice that order of operation. Everybody got that? You don't add the 2 first, then multiply by 2. You multiply by the 2, then you add 2. Yep, stretch by 2, so we got negative 4, and then add 2 to get negative 2. Stretch by 2 to get 4, and then add 2 to get 6. Stretch by 2 to get 0, and add 2 to get 2. So again, I want to consider that description, as she said, it's a horizontal reflection. So this shape should be flipped horizontally when I plot it. So over 2 and down 2, 0 and 6, negative 2 and 6, negative 3 and 2. And it definitely looks like it's flipped horizontally, and it definitely looks like it's stretched. Both those pieces are in play. Good work. I want you to flip to your assignments so I can show you what you should be doing here. Okay, on this worksheet right here, all you're going to be doing is describing how the new graph is different from the original one, which would be f. Okay, so for example, what's this minus 3 going to do? So all you would need to write is down 3. And then for this one, what's the minus 3 going to do? So you just need to say write 3. So on the front page, that's what you're doing, is just giving that short description. Doesn't need to be anything real complicated. Please flip it over. And for this part, what you're, my apologies, the graph came out as G. I wanted the graph to be F. Sorry about that. But what you're going to do is what we just did in our example in our notes, is you're going to provide 4 coordinates for this guy and then the transformation of those coordinates. So let's just make sure we're using the same coordinates here so it matches up with what you're looking at with each other as well as the answer key. What do you think is the first coordinate? Yep, we're going to do 0, 1, 1, 2, we're going to do this. We'll do this corner down here. So we'll do 4, -1. And after 4, -1, we'll then choose 6, 0. Everybody okay with those 4 coordinates? And then, just like we did in class, you'll then produce the new coordinates. If you'd like to sketch it in order to see does it make that change, you could do that as well. This is just a matching exercise to see if you can match them. This last piece here, this is something that we'll be covering tomorrow, so don't feel like you have to be on top of that for tomorrow. But that will be the last piece we'll look at tomorrow. I have your study guide almost complete, which my goal would be to hand it out to you tomorrow. As you notice, we're kind of in an interesting situation here with our class. The red days are days you don't have school. So this is what, I mean, you guys got a lot of time off coming up, don't you? So if you have a little bit of work to get caught up on, good. Get caught up on it, and then you can take your break coming up here. We're going to cover transformations today and tomorrow, and then you're going to get Friday and the weekend and Monday to work on your study guide and ask questions on homework or anything. Your test will be Tuesday. There's no school on Wednesday, Thursday, Friday, Saturday, Sunday, or Monday. You'll return on Tuesday. So you got quite of a break. So get your stuff done in the meantime, and we'll be ready to go. We will miss those tennis people.